93 years. That's the span we're covering today, 1956 to 2049. From the moment AI got its name at a summer workshop in New Hampshire to a projected future where your vehicle anticipates your morning before you're even awake. And what's remarkable isn't the technology, it's the pattern that emerges when you see the full arc.
This is Auto Intelligence. We're Bill and Claire, part of the Auto Agentic team. New episodes every Tuesday. Whether you're starting your day with coffee or catching up on the commute, we're glad you're here.
Today we're walking through something we built, something that took months to research and design. It's an interactive timeline experience at the future of automotive.ai. 23 critical moments, 12 historical, 1 marking exactly where the industry is right now, and 10 projections forward based on forces already in motion.
And when you see it as one continuous story, the fragmentation disappears. You start to see why the automotive industry keeps getting surprised by AI breakthroughs it should have seen coming, why the same pattern keeps repeating across decades.
Here's the pattern. AI breakthroughs happen. The automotive industry either ignores them or adopts them superficially. The structural implications compound. And eventually, and this is the key part, organizations that understood the architecture, not just the tool, they separate permanently from those that didn't.
That pattern has been running for nearly 7 decades, and it's running right now.
So, let's start at the beginning. Summer, 1956, Dartmouth College.
John McCarthy, Marvin Minsky, Claude Shannon, Nathaniel Rochester. They gathered for a 2-month workshop with a proposal that every aspect of learning or intelligence could be so precisely described that a machine could simulate it.
They gave AI its name, its founding ambition, its intellectual scaffolding. And the automotive industry, well, 1956 was chrome, fins, V8s, the interstate highway system. The idea that a machine could think, let alone drive, didn't register.
But that seed planted at Dartmouth eventually produces autonomous driving, predictive manufacturing, intelligent customer systems. This is minute zero.
Fast forward 30 years, 1986. A German aerospace engineer named Ernst Dickmanns makes a Mercedes van drive itself using cameras and computers.
Varmors, it processed visual information in real time, identified road markings, obstacles, adjusted speed and steering. By 1987, it's driving autonomously on closed highways at 96 kilometers per hour.
And the automotive industry largely ignored this. OEMs were focused on fuel injection, airbags, early electronics. But Dickmanns proved that a vehicle could perceive, interpret, and act on its environment using AI.
30 years before Tesla's camera-based autonomy strategy proved him right.
Which brings us to one of the key themes that runs through this entire timeline, the lag. The automotive industry consistently takes 20 to 30 years to absorb fundamental AI innovation. Dickmanns in '86, commercial ADAS in the 2010s, the pattern repeats.
1997, Deep Blue defeats Garry Kasparov. No direct automotive impact, but it put AI on the executive agenda for the first time. The concept that machines could outperform human experts in complex, high-stakes decision environments entered mainstream consciousness.
And Kasparov's later advocacy for human-AI collaboration, rather than competition, that becomes the dominant framework, the one the automotive industry will eventually need to master.
Then we hit 2004. DARPA launches an autonomous vehicle race through the Mojave Desert. 142 miles, $1 million prize. No vehicle finishes. The best performer covers 7.4 miles.
Widely seen as a failure. But here's the thing. 18 months later, DARPA runs it again. 5 vehicles complete the entire course. Stanford's Stanley, led by Sebastian Thrun, wins.
And the talent pipeline this created is extraordinary. Thrun leads Google's self-driving car project. Chris Urmson becomes CTO there, later founds Aurora. Brian Selesky founds Argo AI. Virtually every autonomous vehicle company traces its leadership back to DARPA.
For the automotive industry, this was a wake-up call they mostly slept through. The technology was being developed outside Detroit, outside traditional suppliers, outside the industry's comfort zone.
Which is the second pattern, external disruption. Every major AI advancement in automotive came from outside the industry. Academia, defense research, Silicon Valley. The automotive industry has never led its own AI transformation.
While DARPA was creating that talent pipeline, 3 researchers were keeping neural networks alive through decades of skepticism. Jeffrey Hinton, Yann LeCun, Yoshua Bengio.
Hinton's 2006 paper on deep belief networks reignited the field. The three later shared the 2018 Turing Award, and no one in automotive knew their names.
But every camera-based ADAS system, every computer vision quality inspection tool, every deep learning model running in automotive, it all traces its lineage through work these three preserved through 2 decades of institutional neglect.
Which demonstrates that the most consequential innovations are often invisible to the industries they'll reshape. The automotive industry's AI future was kept alive by 3 researchers the industry had never heard of.
2009, Google launches Project Chauffeur, later Waymo, under Sebastian Thrun. This was a technology company, not an automaker, declaring it would define the future of driving.
Google brought software engineering culture, data-centric thinking, an approach that treated the vehicle as a platform, not a product. The automotive industry's response ranged from dismissal to panic.
And billions in autonomous vehicle investment followed as OEMs scrambled to avoid obsolescence. This is the moment the automotive competitive landscape permanently expanded beyond its traditional boundaries.
2012, AlexNet, Alex Krzyzewski, Ilya Sutskever, and Jeffrey Hinton enter a deep neural network in the ImageNet competition. It wins by a margin so large, it effectively ends the debate about whether deep learning works.
Error rates drop from 26% to 15% overnight. For automotive, this unlocked computer vision. Every camera-based ADAS system, every automated quality inspection, every visual AI application traces back to what AlexNet proved was possible.
NVIDIA pivoted its GPU business toward AI computing, eventually becoming the primary compute platform for autonomous driving. This was the technological inflection point that made modern automotive AI possible.
2016. Joshua Brown is killed when his Tesla Model S, operating on autopilot, drives under a tractor trailer it fails to distinguish from the bright sky. First known fatality involving a commercially available autonomous driving system.
The crash exposed a gap between AI capability and user understanding. Tesla's naming, autopilot, implied a level of autonomy the system didn't possess.
And the lesson here applies to every AI deployment across the enterprise, not just driving. Deploying AI is not primarily a technical challenge. It's a governance, liability, and trust challenge.
2017, 8 Google researchers publish a paper introducing the transformer architecture. The paper's title, "Attention is All You Need," becomes one of the most cited phrases in computer science.
This is the foundation of GPT, BERT, Claude, Gemini, virtually every large language model in existence. It enabled machines to work with language in ways previously impossible.
And this created the architectural foundation for the generative AI revolution that's now forcing the automotive industry to redesign its organizations, not just its vehicles.
2020-2021. OpenAI releases GPT-3, 175 billion parameters, capable of generating human-quality text, code, analysis.
For automotive, this was the moment AI became relevant to the entire enterprise, not just the vehicle. Marketing, customer service, operations, finance, HR, legal. Every language-based business function was now within AI's reach.
And then, November 30th, 2022, ChatGPT launches, reaches 100 million users in 2 months.
AI wasn't a technology story anymore. It was a business strategy imperative. Every OEM, every dealer group, every supplier needed an AI strategy. Most didn't have one.
The result was chaos. Shadow AI emerged. Employees using ChatGPT with company data without governance. Executives demanded AI strategies they weren't equipped to evaluate. Vendors flooded the market with AI everything positioning.
ChatGPT didn't change what AI could do, it changed who could use it. And that changed everything about how organizations must be designed.
Which brings us to 2023-2024, the tool proliferation, automotive's AI gold rush.
CRM add-ons, service chatbots, inventory optimization, marketing content generators, lead scoring engines, sentiment analysis dashboards, conversational AI for BDC, predictive maintenance platforms.
Each tool solved a specific task. None of them talked to each other. The result was coordination debt, the organizational tax of managing disconnected AI systems.
Dealership employees toggling between multiple AI tools daily, data living in silos, conflicting AI outputs creating confusion rather than clarity. The tools worked, the system didn't.
And this is the automotive industry's first encounter with the coordination ceiling, the point where adding more AI tools actually reduces organizational effectiveness.
Each tool was individually useful. Collectively, they created fragmentation.
You're listening to Auto Intelligence, produced by Autoagentic.
Autoagentic is building the intelligence foundation for the automotive industry, but we're not focused on this AI cycle. We're architecting for the next automotive decade.
2024 and 2025 were foundation years. Organizations explored, tools spread, but intelligence remained fragmented. 2026? That's different.
This is the year automotive shifts from pilots to playbooks, from isolated AI use to coordinated intelligence systems.
Autoagentic is working directly with select dealer groups and OEM environments to build and codify those playbooks. From 2027 onward, intelligence moves to the ecosystem level.
By 2030, agentic orchestration becomes the standard for industry leaders. That's the future Autoagentic is building toward.
Now back to the timeline.
So we've walked through the foundation years, 1956 to 2024, 12 moments, and the pattern is clear. External disruption, industry lag, superficial adoption.
Which brings us to the moment that functions as the hinge of the entire timeline, the breakpoint, 2025 to 2026.
This is where the audience is right now.
By 2025, the symptoms are consistent across the industry. Dealership employees toggling between 6 or more AI-assisted tools daily, losing time to context switching and data reconciliation.
OEM product teams receiving AI-generated market analyses that contradict AI-generated customer insights from another system. Service departments with AI diagnostic tools that can't access the AI-powered customer history tools used by sales.
The coordination ceiling, the point at which the marginal cost of one additional AI tool exceeds its marginal benefit because the organization lacks the architecture to integrate it.
And leadership teams begin to recognize a distinction that was previously invisible: the difference between AI tools and intelligence architecture.
Tools solve individual tasks. Architecture coordinates intelligence across the organization. Without architecture, tools create fragments.
The question shifts from what AI tools should we buy to how should information flow through our organization and what role does AI play in that flow?
This is also when the concept of the transactional age versus the intelligence age gains traction. Organizations built on transactional logic, linear workflows, functional silos, periodic reporting, they can't absorb AI effectively.
The organizational architecture must change before the technology can deliver its potential.
And this is the moment of honest reckoning. It's painful, but necessary. Because what comes next requires organizations to redesign themselves, not just their tool stack.
So let's project forward. 2026, 2027, the regulatory fracture.
The EU AI Act reaches full enforcement. Risk classification, mandatory human oversight, algorithmic transparency. The United States deregulates aggressively. Minimal federal framework, industry self-governance.
China builds its own autonomous framework with mandatory black box recorders and government data access. 3 markets, 3 regulatory philosophies, 3 compliance architectures.
Every global OEM must now build parallel governance systems. The cost and complexity of regulatory divergence becomes a permanent feature of the landscape.
AI governance is not optional and not universal. Organizations that treat governance as a legal department function rather than an enterprise-wide design discipline find themselves structurally disadvantaged.
2027, 2028, intelligence architecture emerges.
Leading organizations begin replacing fragmented AI tools with unified intelligence architecture, data lakehouses that consolidate siloed information, knowledge hubs that capture and distribute organizational expertise.
Coordinated AI agent systems that share context across departments. BMW's Neue Klasse platform becomes a reference case for software-defined vehicle architecture.
VW Rivian partnerships demonstrate supply chain intelligence integration. The first organizations to achieve unified intelligence architecture begin compounding advantages that become increasingly difficult for competitors to match.
And this is the proof point. The problem was never AI technology, it was organizational architecture. These early implementations demonstrate what becomes possible when organizations redesign themselves around intelligence.
2028 to 2030, embodied AI enters manufacturing. Humanoid robots and agentic AI systems move from pilots to production on automotive factory floors.
Tesla's Optimus figures robots, AI-coordinated manufacturing cells transform the economics of vehicle production. The factory becomes an intelligence system. Humans, robots, and AI agents collaborating as an integrated workforce.
Routine manual tasks migrate to machines. New roles emerge at the intersection of robotics and AI supervision. Factory consolidation accelerates around scale players who can afford the capital investment.
High-wage manufacturing regions gain unexpected competitiveness as automation equalizes labor cost advantages. AI moves from the screen to the physical world.
2029 to 2031, AI agents join the workforce.
Not tools used by humans, but autonomous actors handling defined responsibilities. A service scheduling agent doesn't wait to be queried. It continuously monitors vehicle telemetry, service capacity, customer preferences, parts availability, proactively scheduling maintenance.
A supply chain agent monitors global logistics, adjusts orders based on demand forecasts, escalates exceptions only when thresholds are exceeded.
Managers evolve from directing human teams to orchestrating human AI systems. Agent governance becomes an operational discipline, defining authorities, escalation protocols, audit trails, performance metrics.
And the workforce doesn't shrink as dramatically as predicted, it reshapes. Routine cognitive work migrates to AI agents. Human roles shift toward judgment, relationship management, creative problem solving, exception handling.
This is the moment AI stops being a tool humans use and becomes a colleague humans work with, which requires fundamentally different organizational design, governance, and leadership.
2030 to 2032, the security arms race.
As vehicles become networked AI agents connected to each other, to infrastructure, to the grid, to their owners' digital lives, the attack surface explodes.
The first coordinated cyber attacks on connected vehicle fleets forced the industry to treat cybersecurity not as an IT function, but as a core design discipline.
Automotive security operations centers become standard. Supplier cybersecurity requirements match safety requirements. AI-powered defense creates an ongoing arms race with AI-powered attack.
Intelligence creates vulnerability as surely as it creates capability. Every connection, every AI decision, every data flow is simultaneously a source of value and a potential point of compromise.
2031 to 2033, the vehicle as energy node.
The electric vehicle stops being a car that needs charging and becomes an energy asset that happens to move people. AI manages bidirectional energy flows between vehicles, buildings, and the grid in real time.
Vehicles buy electricity when it's cheap, sell it back during peak demand. Fleet operators discover that energy arbitrage generates meaningful revenue.
The economics of vehicle ownership change fundamentally. A vehicle that participates in the energy ecosystem costs less to own and generates revenue.
And this creates a competitive dynamic that pulls the entire industry toward energy integration. The automotive industry's boundary expands beyond transportation into energy.
2033 to 2035, the network awakens, OEM dealer intelligence integration.
Intelligence architecture extends beyond individual organizations. Vehicle telemetry flows simultaneously to OEMs for product development, dealers for proactive service, customers for maintenance awareness.
Customer preference data informs both dealer-level personalization and OEM product strategy. Demand signals flow from dealers to production planning in real time.
The automotive value chain stops looking like a supply chain and starts looking like a neural network. Distributed, interconnected, capable of collective intelligence that exceeds any single node.
And the organizations that succeed share a common trait. They approached intelligence sharing as mutual value creation, not data extraction.
2035 to 2038. Autonomous intelligence systems. The organization learns itself.
AI systems within automotive organizations begin operating with significant autonomy, not just executing tasks, but adapting processes, optimizing workflows, improving their own performance without human direction.
The organization becomes a learning system rather than a managed hierarchy. The competitive gap between intelligence-architected and traditionally managed organizations becomes severe and potentially irreversible.
New business models emerge: vehicle hours, subscription mobility, performance-based insurance, all enabled by data and coordination capabilities that only intelligence-architected organizations can deliver.
This is not automation. It's organizational intelligence. Automation replaces human work. Organizational intelligence augments human judgment. The distinction defines the era.
2040 to 2045, the living organization, continuous adaptation.
Organizations evolve from static structures that periodically reorganize to living systems that continuously adapt. The automotive company of 2040 is not a traditional organization using AI.
It is an intelligence system with human participants. Dealerships transform into experience centers and community hubs. The workforce stabilizes around high-skill human roles complemented by AI agents.
Revenue models shift from transactions to ongoing relationships. Vehicle development cycles compress. Vehicles themselves become learning systems that improve after purchase.
The completion of organizational transformation. The static hierarchy gives way to continuous adaptation.
Which brings us to the final moment. 2049, the intelligence age fully realized.
A woman wakes in Toronto. Her mobility provider has already assessed her calendar, weather, road conditions, energy prices. The right vehicle is waiting. Not her vehicle in the ownership sense, but the right vehicle for today.
She didn't request it. The intelligence has been anticipating this morning for days. The vehicle reroutes around traffic, negotiates an energy top-up at a charging point running a solar surplus.
Surfaces documents for her 9 a.m. meeting. When she arrives, the vehicle doesn't park. It joins a local fleet. The energy it absorbed is sold back to the grid during the afternoon peak.
And this isn't luxury. In 2049, it's the default. The systems orchestrating it are invisible precisely because they work.
The distinction between buying a car and having mobility dissolved years ago. The organizations delivering this experience are unrecognizable by 2025 standards.
They are intelligence ecosystems, fluid assemblies of human talent, AI agents, data infrastructure, partner relationships that continuously reconfigure around objectives.
And the most striking aspect of the transformation is its inevitability. Each step, from Dartmouth to deep learning, from ChatGPT to intelligence architecture, followed logically from the one before.
AI was never going to remain a tool. It was always going to become the operating system of the organization.
So what does this mean if you're making decisions about AI in the automotive industry right now?
First, recognize where you are. Most of the industry is at or near the breakpoint, the coordination ceiling. You've got tools, what you need is architecture.
Second, understand the lag. The automotive industry takes 20 to 30 years to absorb fundamental AI innovation, which means the breakthroughs happening now won't reach full operational maturity until the late 2030s or early 2040s.
But the organizations that architect for that future starting today, they'll compound advantages that become irreversible.
Third, this is not a technology problem, it's an organizational design problem. The question is not what AI tools to buy, the question is how information should flow through your organization.
And fourth, the human role doesn't shrink, it reshapes. The irony of the intelligence age is that it makes certain human capabilities, judgment, relationships, creative problem-solving, more valuable, not less.
The timeline we built at the future of Automotive.ai walks you through all 23 moments in detail. Each one has a full strategic brief, 800 to 1,500 words covering what happened, why it matters, who the key figures were.
It's an interactive, scroll-driven experience. You start in 1956 and move forward through history and projection, era by era. We built it because the automotive industry needed connective tissue across fragmented AI conversations.
When you see the full arc, the pattern becomes visible, and the pattern tells you where this is going, whether any individual organization is ready or not.
The future of Automotive.ai. We'll put the link in the show notes. And if you're working through how intelligence architecture applies to your organization, AutoAgentic offers strategic consulting and the platform infrastructure to implement it.
You can explore that at autoagentic.ai. There's also a free playbook from the transactional age to the intelligence age, 181 pages, available for download at autoagentic.ai/book.
This episode was produced by the team at AutoAgentic. Special thanks to Barry Hillier, CEO and founder of AutoAgentic, the architect behind this timeline experience and the Automotive Intelligence Pyramid Framework.
We want to hear from you. Topic ideas, industry stories, companies and people shaping mobility, feedback on the timeline. Email Barry at autoagentic.ai.
The pattern has been running for 7 decades. External disruption, industry lag, and eventually the organizations that understood the architecture separate from those that didn't.
The question is not whether the intelligence age arrives. The question is whether your organization architects for it or gets reshaped by it.
Thanks for spending this time with us. New episodes every Tuesday. We'll see you next week.